All right, on 3.4, Alicia is working on computer animation for her programming class, and she needs to move the dog around the computer screen. It's really important that we read the directions on each one of these problems. Her first task is to move the dog from a starting position in quadrant 1. This is the starting dog in quadrant 1. We want to end in the dog's position in quadrant 3. So this is our ending position. So some of you messed up by transforming this dog to get to this one. So make sure you read the directions, which one's your starting dog. We're going to describe in words, not with a ordered pair rule, what transformation Alicia will need to use in order to move the dog. And we want to be specific. That means every time we say translation, we have to tell what direction and how many units. Every time we say reflection, we have to say across what line. Every time we say rotation, we have to say the number of degrees, direction, and around what point. So I told you on the video and in class that if you have 2 or more transformations, always save the translation for last. So we'll slide the dog into place after we get it positioned in the correct orientation first. So the first thing I notice is these 2 dogs are facing in opposite directions. So I want to reflect this dog so that it is turned the direction that my final dog is in. Now, there's lots of things I can reflect off across, and they all need to be vertical lines. But in number 2, I'm going to have to write an ordered pair rule for that transformation. And I only know how to write the ordered pair rule for 3 reflections so far. We know how to reflect across the y-axis, how to reflect across the x-axis, and how to reflect across the line y equals x. Well, since I want this dog to be facing the opposite direction and not flipped upside down, I'm going to reflect across the y-axis. So in my words, I'm going to put reflection across the y-axis. Now remember, you cannot reflect across a point. 1 or 2 of you put reflection across the origin, and that does not make sense. So the first thing we're going to do is reflect across the y-axis. So the nose of the dog right now is at the point 3, 2. After we reflect it across the y-axis, it will end up at this point, which is -3, 2. It changes the sign on x when you reflect across the y. So now we can see what translation we need to do to get that nose lined up here. We got the dog facing in the right direction. Now we just need to slide the dog into place. So I need to go to the right 2 units, and I need to go down 5 units. Now some of you in your description said move. Move is not a transformation. The transformation that we are doing is called a translation. So we are going to translate, and don't say over. We need to tell which direction. Translate right 2 and down 5. So that is using words with our 2 different transformations that are needed. Reflection across the y-axis, and then a translation right 2, down 5. So now we're going to write that as an ordered pair rule in number 2. Every time you write an ordered pair rule, you need to start off with X, Y, arrow every single time. It did not tell us to write an ordered pair rule for the nose. So some of you used a specific point on number 2. We're doing it for the whole dog. So we're using generic ordered pair rule in X, Y terms to move the whole dog, not just the nose. And so the very first thing I know that I have to do is reflect across the y-axis. And I know that changes the sign on x. So all of these points are going to become the opposite of x, y when we reflect across the y-axis. Now these new points are going to be translated to the right 2 and down 5. So that means that when we go to the right 2, we're adding 2 to the x, but my x, remember, is the opposite of what it began as. So it's opposite x plus 2, and going down 5 subtracts 5 from the y. So we could write that in one single step as x, y, arrow, opposite x plus 2, y minus 5. So if you were in class, I told you check the nose and make sure it works in this transformation. So if I put 3 in for x, I'd have -3 plus 2, which gives me -1, which is the x of the nose in the final position. This is the point -1, 3. So when I put in 3, -3 plus 2 is -1. When I put 2 in for y, 2 minus 5 is -3, and that's what I want it to end up as. These two answers should go together. What you put in words here should be what you have in ordered pair rule here. So the points on this, the way that I graded this is number 1 was worth 5 points. I was looking for the word reflection. That's a point. The line that you're reflecting over, well, the y-axis is a point. And then translate was a point. Right 2, down 5 were 2 more points. So this was 5 points total. The number 2 was also worth 5 points. 1 point just for getting this XY arrow part. And then the opposite of X was a point, adding 2 was a point, a regular Y was a point, and -5 was a point. So that's where all those points came from. All right, and then on number 3, now we want to move the dog into his doghouse. What single transformation, so just a reflection, just a rotation, or just a translation, will move the dog so that his nose is at the center of the doghouse? We do not need to flip the dog. We do not need to rotate the dog or any other thing to get it oriented in a different way. We just simply are going to translate it into place. So the nose is here. We want it to be in the center of the doghouse, which is here. So we need to translate it to the right. 1, 2, 3, 4, 5, and up 2. So translate right 5, down 2. Again, don't say over 5. I don't know if you mean over to the right or over to the left. Use correct terminology here. This was worth 3 points, 1 for the word translate, 1 for right 5, 1 for down 2. On the back, we're writing an ordered pair rule again. So remember, every single time you will write XY arrow. Every time you're writing an ordered pair rule, we want the dog to end up on his back. So we're flipping him over. The word we use for a flip is a reflection. When you reflect, you always do so across a line, and the line we're reflecting across is the x-axis. So the nose that is at 3, 2 ends up at 3, -2. Because when we reflect across the x-axis, we change the sign on y. So that's what I'm going to write here in my ordered pair rule. XY is mapped to x opposite y. Don't put numbers here. We're not talking about a specific point. We're writing a generic ordered pair rule for the whole dog. Number 5, we're given the initial point, the translation vector. We want the coordinates of the terminal point. So remember, if you'll write this translation vector right underneath your initial point, that tells you the math to do to the x-coordinate and to do to the y-coordinate to get your terminal point. So since we started at 2 and we're going left 3 units, that's what the -3 means. 2 minus 3 would give me my new x-coordinate of -1. We were at a y of 1. We went translated up 4 units, so 1 plus 4 gives me 5 as my y-coordinate of my new point. Number 6, writing a translation in vector notation. It even reminded you how to do that. You just put the translation distance into angle brackets, your horizontal distance first, and then your vertical distance. So I get my horizontal distance in the change in x. My x went from a -1 to a +4. So it went to the right 5 units. So I would put a +5 in the first place of my vector notation. The y will give me my vertical move, and I went from a +3 to a -2. So I went down 5 units. So -5 would be my vertical translation amount. So this is your answer in vector notation. We're doing the same thing on number 7 and number 8, writing the vector notation for the translation. So here's my initial point, here's my terminal point, because that's what the arrow is pointing to, and that's the direction we're going. So you can see that we're going to the right and up in this translation. The number of units to the right is 1, 2, 3, 4, 5, 6. So that's the number that will go in the first spot of my vector notation. And we're translating up 1, 2, 3. So 3 is the second number in my vector notation. Remember to use angle brackets, not parentheses. And the second one, you can't really see grid lines, but you're given the coordinates. So we can tell, again, the arrow tells us we're going this direction, which is right and up again. And so we can use our x to see how many we're going to the right. We're going from -3 to +4, so that means we're going to the right 7 units. And then the y will tell us how much we're going up or down, and we know we're going up. -2 to +1 is 3 units. So this is the vector notation for that. So remember, always put points in parentheses, vectors in angle brackets.